All right, let's get started. Good morning, good afternoon, and good evening, everyone. Welcome to yet another exciting session of Apex Officers JPAC. Today's topic is understanding the Apex application development lifecycle. Before we proceed further with the topic, always build applications 20 times faster with 100 times lesser code. Visit apex.oracle.com for all the information related to Apex. Resources we have on apex.oracle.com. This is a one-stop shop and official website for Oracle Apex to get information on the platform, use cases, learning materials, community, and success stories as well. Get to get to know more about Apex by visiting apex.oracle.com. In this session, we are going to understand the Apex application development lifecycle from Steve Munch. A little bit about Steve. Since February 1990, Steve has helped customers make the most out of Oracle application development tools. He has been a tool support engineer, product manager, a doc writer, a technical evangelist, a developer, and an architect. He has joined the Apex development team in 2021, being one of the first Oracle's bloggers. He continues to blog about Apex on diveintoapex.com. The website name I'm repeating again, diveintoapex.com. Today, he's here to help you better understand the Oracle Apex application development lifecycle. Without further delay, let us welcome Steve. Welcome, Steve. The stage is yours.
Thank you. Good afternoon. So I plan to talk about features today that are all in production, but just in case I mention a feature that has not been released yet, please make sure any purchasing decisions are based on features that are already in the product. So at the highest level, let's review what the life cycle of application development means. Put very simply, it means that end users that are using your applications report bugs and suggest improvements to you and your team. Your team selects a set of bugs and features to include in the next milestone, some particular set of time, maybe a few weeks or a few months. Your team has the goal of delivering repeatably a high quality set of improvements to your application. It's really simple. That's the main goal, but following and delivering on that goal has a number of requirements. Of course, you need to track those bugs and features, all the details that people have reported and the feature requests that they've made. Select a few of those and decide which ones will require a long amount of time or a short amount of time, and choose a nice set for the next milestone. Work together as a team using Apex to minimize the conflicts as you're working together to implement those bugs and features. And all the while, make sure that you're managing the history of your project so you can see over time all those improvements. If necessary, go back and move back to a previous set of changes. We'll talk about how you can test your applications, your user interfaces, and measure your code coverage. And then how you can package and deploy your applications to different environments as you're setting up your team to be successful at delivering this repeatable set of goals. And if you're working on a mission-critical application or have a larger team, a few additional steps might be in order. Things like inspecting your code for performance, security, and quality. Working even more than possible with a single instance in isolation of each other. We'll talk about how you can accomplish that as well. And then finally, larger teams may benefit from automating the build process. And we'll talk about what tools are available, open source tools and others, to accomplish that job. So let's just start so that everybody's on the same page with a quick review of the Apex architecture and the kinds of artifacts that your application comprises. So of course, when you're working in Apex, you're working in the context of a workspace. You might be working on multiple applications. Those applications are comprised of pages and components. Each application might have its own schema for keeping things organized. or maybe they share a schema, mixing the tables and the procedures. That's up to how you organize your application. But it's also important to understand that an application that end users believe is a single application might actually be composed of a set of smaller, what we might call mini apps, to organize and break down the larger set of functionality, so that if you're building an application to manage a conference, you might have a library application with shared components in it, maybe an application that's managing the speakers for the conference, a separate application for the sponsors, and a third application for the attendees. And they all will share a conference schema. So it's important to understand how you can break down a more complicated functional application into smaller units, and we'll talk more about that, how you do that. Now, because of Apex's architecture running inside the database, the application definitions that you create live inside the database in a set of tables that the Apex engine manages for you. But that means that your application that's being executed or being developed is only inside the database, the current version of the app. And that means that in order to perform many of the lifecycle tasks that we'll talk about, you need to understand how to extract or export the application definition from the Apex environment to the file system, so that you can use common tools to work with the application definition files, be that a source control, be that text editors for reviewing changes to your files. So it's important to understand what files get produced and where those files will live once they're exported from the database to the file system. Some of those files that are part of the export will be used for the installation or the import. Other ones, like the YAML format that we'll see some examples of, are not used currently for the import and are primarily for helping you review the changes. And so we'll see that some of the files are really kind of a side importance for use in the development environment only, and other ones are important to keep for the purposes of deployment. Of course, when you go to import an application, a subset of those exported files that represent the application definition that Apex can execute will be imported into a workspace in a target environment. So let's take the first step of the application lifecycle, which is understanding how to track bugs and features, and what functionality Apex makes available if you're not already adopting a third-party tool, or maybe a tool that you built in-house for tracking your bugs and features. It's important. Sometimes developers don't notice at the top of the Apex application development window. Maybe you only work with the app builder and the SQL workshop, but just next to that, there's the team development choice, which maybe you've never explored, but it's a built-in functionality that Apex provides for teams to create and track bug reports, feature requests, and assign those to different developers on the team, group those into milestones, assigning a target date, and use that maybe as the development manager on the team to organize the development of your repeatable milestones that your team is delivering. So when you're creating an entry in this team development system, you can use the markup language to create the description of what the bug or the feature was. You can include graphics, maybe screenshots that are either showing what the problem is, or a designer might be suggesting what a page should look like. So it's a bare bones system, but it has all the features for applying tags and defining your own tags to qualify those bugs, assign them to developers, organize them into milestones, and search for them. So it's a nice built-in functionality for doing that tracking if you don't already use a system like Jira or a custom bug or feature database of your own. Next, we'll take a look at what functionality Apex provides to allow teams to work at the same time in a shared environment, which is really one of the powerful features that make Apex very productive for teams of any size, but especially small teams like to work in this environment where maybe developers on a team are working on different apps or what we called mini apps before in the same workspace, or possibly even multiple pages, different components in the same application. It's good to know what kind of protections are in place to make sure developers don't accidentally stomp on each other's changes or lose each other's changes by accidentally making a change that another developer's already made. So we'll talk about ways to protect against developers changing the same page at the same time. But if that does happen, understand that Apex implements a lost update protection in the builder environment at the property level. So if accidentally two developers make a change on one page, if one developer changes the label of a field and another developer changes a button, they can stay out of each other's way if they don't change exactly the same things, but it's not really the best way to work. It's good to know that that protection is there though. So if a developer does make a change, you'll see an error on the screen like the attribute has already been changed by another user, very similar to what you might see for your own business data if two users try to modify the same employee record in the database. Similarly, if two developers create the same LOV with exactly the same name at about the same time, you might get an error like unique constraint violated when the second developer creates the LOV that already exists. And similarly, if both developers modify the same component, like a list of values, for example, one just after the other, they might see an error like the current version in the database has changed. So Apex does implement these kinds of protections so that you won't lose work, but there are better ways that Apex provides to send a signal to your teammates to stay out of working on a particular page while you're working on it. So let's talk next about that functionality, which is our page locking feature. You may not have explored this yet, but at the top of the page designer, there's a little lock icon. And if you click on the unlock icon, you can lock a page and provide a nice message so all the rest of your team members can see what you're working on. Once you've locked it, the icon will turn a different color and show that it's locked. Let's say that that's Steve working on a page. If a colleague named Vicky looks at a page, in the list of pages, she'll see that it's locked and who locked it. And if she goes to view the page will be read-only so that she can see what's there, but she won't be able to make changes to it while the page is locked by a teammate. So page locking is a simple way to avoid team members changing the same page or component that you are working on. Then when you're done, you can click the lock icon and unlock it and make that page available for others to modify again. But in the Apex 23.2 release, there's an even better way to do shared development in the same instance. And that's a feature that's called the working copy. And what that allows is developers like Mark and Grace to create their own copy of the application to work, let's say, in private, although the application working copy can be visited by other developers, but most developers will work just on their own working copy. Mark can create a working copy to work on his ticket number 2. Grace can create a working copy, and then they can proceed to work in parallel on their copy of the application on whatever pages or features they want. It's still a good idea to lock the pages in the main application to let your teammates know that those are being worked on. But let's take a quick look at what happens when Mark decides he's done working and he wants to integrate his changes back into the main application. That's called merging back into main. And here's an example of what it will look like. Mark chooses the merge into main option from the menu. Apex Builder will compare Mark's working copy with the main application and show Mark a list of all the new and changed components and pages. For any component that's changed, Mark can look at a diff to compare side by side a high-level view of what has been changed to make sure those are the things he wants to merge in. Clicking next after selecting what components, he can choose whether to delete the working copy after its merge and click confirm. And those selected components will be now merged back into the main application, where then the team development manager can archive the main application for source control purposes that we'll talk about in the next sections. So in parallel, Grace might be working. She can refresh her working copy to include anything teammates have merged into main as she continues a longer development feature. And then finally, she'll merge into main, and she might decide to keep her working copy around to continue working on some other aspect of it. So all of those things are possible while still working in the shared development environment that's very productive for smaller teams. And finally, Pat, the development manager, will export the application, as we'll see, to the source control like GitHub every day or whatever the appropriate period is for that team. The last few things I'll talk about in this section are some techniques to be aware of. We talked about mini apps, but how do you actually do that? So we'll talk about things like creating a shared menu or shared LOVs. You can create those in a core or a library application, and then other applications or mini apps can subscribe to those components so that they can share the same definitions. And if they get updated, they can simply refresh their copy of the menus or copy of the shared LOVs. That way, an end user sees exactly the same menu, and they don't even understand that the application was developed as a set of smaller modules. And so that's good from the end user's perspective. Be aware that there's a setting under the authentication scheme called workspace sharing that needs to be set so that you can share the same menus across and the same authentication across these mini apps to give that end user look and feel of one unified application to your users. And similarly with list of values, that's another popular kind of component that might live in a library application and be shared to various mini apps that would benefit from it. Let's talk next about source control. When you're working, as we talked about at the beginning, with an application in the Apex Builder or running an application as an end user, what's installed in the database is just the current app version only. The database, while Apex does take automatic backups periodically, or as a developer, you can proactively make a backup of your application and have it stored inside the database. Really, the current version is the only version that the database knows about. And it's up to your team and your job to preserve the history of your application over time by taking point-in-time snapshots of your Apex application and your database schema definitions. Doesn't have to be every hour, of course. It might be once a day or once a week, whatever makes sense for your team. But taking that snapshot and storing them in a source control system gives you the milestones and a history of the application very similar to something like the Macintosh time machine functionality, which keeps a copy of what your project looked like or what your files looked like at any point in time along the arc of a particular release or functionality, which might last many years. And so storing the application definition files in the source control allows you to answer questions much more easily of who made a change, what got changed, when it got made, and why was that change made, assuming your developers always associate a useful message with each time they make changes to the product. So Git is probably the de facto standard, although there are other source control systems like Subversion and others that are popular. I'd say Git is probably the most popular at the moment. There are free and paid hosted options, both outside of Oracle as well as on the Oracle Cloud for that. Git, effectively, to get started with Git, you simply create a repository that will be your time machine for the project in some remote repository where your team memory will live. That's over here on the right with my team remote repository. And then by cloning that repository into a local team work area, you're able to establish a local copy where your team development manager will export the files from your Apex app over and over on a periodic basis and push them into that remote repository. So how does that work? We talked about exporting, and we'll see exactly how you do that in just a second, but the application definition is exported from the database to a set of files and folders in the file system in your local work area. You commit those changes to your local Git work area, and Git keeps track of all the differences that have been made in a special folder called .git, which usually you don't look in, but just know that it's there so you don't accidentally delete that folder thinking it's not required. Once you make a commit changes to your local work area, you can push those changes back up to the team remote repository, and it not only serves as a backup of your changes, but as we mentioned, it serves as the history over time of all those changes. So the next time your team makes a set of changes, you export again to your local work area and commit those changes and push them up to the repository. You can later review all of the lifetime of your application using functionality that's provided by GitHub, GitLab, OCI DevOps, Visual Builder Studio, whatever tool you're using to work with Git has features that let you do that. Now, exporting an application, as we'll study in the next few slides, requires a database connection to the Oracle database where Apex is running. But if you're working in an Apex service or in an environment where you don't have database connectivity, here are some QR codes to two great articles that explain the options that allow a REST-based export and import functionality. The one on the left, that's from 2023, is the most up-to-date article that talks about features that are built in to the ORDS server that allow exporting and importing Apex apps with a ready-made endpoint. An earlier article written by my colleague Karsten also explains how to use REST, and it explains how you can create your own custom interface for doing that if the built-in ORDS functionality doesn't meet your requirements. So now let's talk about what you do where the rubber meets the road to export your Apex app to files. You use SQL-CL. That's the command line tool for accessing an Oracle database. It has a built-in command called Apex Export, and you simply provide the application ID of the app to export. Since it's better for source control purposes to see each component and page in its own separate file, we use the split option. Every time you export the application, if you include the date that you did that, that will show as a difference in the files, even if nothing else changed. So we skip the export date as part of the way we want to export the application. And we'd also like to ensure that the IDs of all the components, those primary keys that are in the Apex tables, don't change over time. So we use the export original IDs option. And that way, what changes in each file is only what your developers on your team has changed. And that's the most useful version of the export. If you use the supporting objects feature, you can include those with a flag. And finally, you can ask the export utility to include not only the application source, which is the important part for doing the installation or import later, but also an option called readable YAML, which makes it very easy for comparing the code when you review what your teammates have done. The YAML is extremely useful, and we'll see examples of that. The database objects, which always are a part of your Apex application, there's 3 different strategies you can use for managing those. Some teams like to completely manage that themselves. I call that the fully manual strategy. You write your own scripts. Those can be for installing. You might write different scripts for performing upgrades. That's really like the advanced option that some teams prefer. You can also have a fully self-contained option that Apex supports using the feature called supporting objects. Apex provides a built-in facility for packaging, install, and upgrade scripts together with the application, along with some conditional logic that you can provide so that scripts will only execute under certain conditions. You can package that as part of your Apex application itself, and those scripts will automatically run when you install the app. And then the third option is a fully automated solution using Liquibase, which is a built-in feature of SQL to generate an XML representation of your schema and then intelligently figure out what's different in a target environment and apply those changes. So we'll look at that third option, the fully automatic option. That's another command you can run from SQL. Also comes with a split option to have each component be in a separate XML file, each table, each view, each trigger. As an important option to be aware of is the filter option, which lets you put a small SQL predicate to, for example, only export the objects whose names are like ABC underscore. That way, maybe if you've got different sets of product schema objects, you might choose only the ones that go with your current application by filtering on their name or any other predicate that's appropriate. Similarly to the Apex export, that exports the database artifacts to the file system. And so, of course, you could type those commands every time, but why would you want to do that? Normally, you'd probably write yourself a script which would automate the appropriate commands to export the Apex application, export your database objects. And so I'm going to show an example of a script like that that's maybe not exactly what your team will use, but it's a starting point, and it can be modified or at least used as an example to be a starter script to perform the export in an automatic way. I call that script Apex export to Git. You run this command. The only thing that changes each time is the application ID, the target local Git work area, and then the username password that we need to connect to for accessing the Apex and database objects. And everything else is always the same every time once you give those parameters, and it goes through a set of steps. I prefer to create a temporary directory, export the app and the database into that temporary directory, and then copy the appropriate files to the Git work area. I like to organize those files into an application directory and a database directory. That way they're not named F and then a number that maybe you didn't choose. So that's one way to do it. You can do it whatever way you like. And then finally, you add those files to your Git work area. Once they're in your Git local work area, any tool that supports Git like VS Code will allow you to see what files have changed. It's smart about showing only files that have actually changed, and it'll let you review those changes file by file so that you could make sure there's not extra changes or unexpected changes. And then right from your favorite Git tool, you can add a nice commit message, click on the commit button, and then synchronize those changes to push them to your remote repository. There's some additional VS Code extensions like Git Graph or Git Lens, I believe is the second one that's popular, that can show you a more timeline view of your project that might help you see what developers or what team milestones have been checked in over time. And reviewing each change in the YAML file format lets you study only the interesting information that's been changed and not the SQL commands that are part of the normal Apex export files. So the YAML files are very useful for this side-by-side diff operation. Let's talk next about how you can, what tools are available for testing your application, which is an important part of the dev lifecycle to make sure that adding new features or fixing bugs does not break anything that used to be working in your application. So because most code in an Apex application that's business logic is written with PL SQL, the obvious choice for testing your business logic is the popular open source tool called UT-PL SQL. You use normal PL SQL packages to create your suite of tests with special comments that look like --% to help the UT-PL SQL understand which procedures in your package represent tests. So here I've got two tests, one that tries to validate that a date is not in the future, one that tries to validate a United States phone number. So these special annotations let you give a name to your test suite, identify the tests, and then within the body of your test package, you perform a set of steps that exercises your business logic and then add in a number of these ut.expect lines of code, which says what you're expecting to be the correct answer or the correct behavior. And then this makes a repeatable set of tests you can run to ensure that you haven't changed any behavior that your application is expecting to stay working correctly. It's very nice. You can run your UT-PL SQL tests right from the Apex Builder in the SQL commands window with a simple ut.run. And you see the results right in the output window there. You can also run them from the command line using the UT-PL SQL command line tool and providing a database connection. That's useful if you want to incorporate that into a set of scripts or some automations that we'll talk about later. You can provide additional options to UT-PL SQL so that not only does it run the test to tell you if they succeeded, it can also show you code coverage, which is important to show you, for example, which lines of code in your business logic have been exercised by your tests and which ones, shown in a different color, still haven't yet been exercised. So those are opportunities for creating future tests that would do just the right set of steps or pass just the right arguments to cause other parts of your code path to be covered by your tests. And that raises the confidence that your team has in making any changes that they make to fix a bug or add a new feature, so that it's always making steady progress towards your goals of adding that functionality that your end users are demanding. If you use SQL Developer, just a quick note that in the last month, we've released also a VS Code version of SQL Developer that has a nice dark mode, but I don't believe this feature yet is part of the VS Code. It will most likely be in the future. But using SQL Developer, you can also directly run debug, and see code coverage information about your UT-PL SQL tests. So now let's quickly talk about how you can simulate a robot end user using one of many tools. The most popular one that internal teams at Oracle use these days is called Cypress. It's an open source tool that allows you to write scripts with simple commands like get to get values of fields, typing things into fields, clicking on elements of the user interface. And it has a nice browser-based, the should functions are like the UT-PL SQL expect, so that you can write a test that says that this field should have this value if it's working correctly. And then you can debug and run your tests using a browser extension that Cypress provides. So it's a nice set of functionality for incrementally building up and then running the tests. They can also be run in what's called a headless way. So as part of an automation, you can run all of your unit tests in PL SQL, run all of your Cypress tests, and then review the results in a HTML or PDF format. So let's talk about later in the life cycle. You've made a bunch of changes. You now want to make an installable archive to remember a particular snapshot that you think is a release that would like to be tested by your QA team or maybe installed in a production environment. So this is the simplest part of the lifecycle. Since Apex is just those files of metadata, remember that the YAML files do not get used at the moment for installing the application, so that archive only needs to contain the .SQL files that are part of the export of your Apex app. And so I built myself a script called apex get to build zip, and that simply creates a zip file with the current date of the year and the month and the time appended to the end of the name of the app. And that includes just the contents of the application folder and the database folder if you're using the Liquibase approach for your database objects. So it only really needs one argument. My script just needs to know which Git work area you want to zip up the current version of, and it will create you the zip file for that. We'll talk how to deploy that in just a second, but before we do that, let's talk about how it's important to strive to have separate environments for your development work, your test work, and your production work. And one of the reasons is just for your own peace of mind as developers. You want to work without worrying that you're going to disturb the users who are currently getting their job done using your application. So it's best to make it impossible to disrupt the end users by keeping these environments separate. And each group, whether they're the developers, the testers, or the production end users, are going to be most productive by having these be separate environments. Apex provides some nice features, simple features, but nice features for keeping developers aware of which environment they're connected to. You can use the environment banners and provide a particular color. For example, the green color might be it's okay to make changes in the development environment. The blue might be the color of ice or the color of frozen. That's for the test environment where you don't want to make changes there, but you might be testing some small fixes that will bring back into your development environment. And then finally, red for the prod environment, like red is a stop sign. Red means don't make any changes here. Go back to development and make those changes so that you don't accidentally shoot yourself in the foot. The way you change that is under the settings, define environment manage service, and define environment banner. You can type in the text, control if it shows on the left or the top, and pick a nice color. The second thing I'll point out before we talk about the two primary ways you can keep the separate environments is the workspace ID. You may not be familiar with the workspace ID, but it's important when you set up these environments that you be aware of it so that you can create separate environments with exactly the same workspace ID if you have that option. So the way you can find your workspace ID, which may have been assigned by the system, is under the question mark help icon in the About Oracle Apex. If you scroll down, you'll see a workspace ID. Just copy that to the clipboard so that you can paste it into other environments when you're defining your test and your production workspace. Now, the best way to set up, and I'll explain why it's best, is having separate Apex instances for the dev, the test, and the prod. That means that each one can have exactly the same workspace name, Apex app in my example, the exact same workspace ID, the exact same schema name. Keep everything simple. And the only thing that will be different is each machine or environment might have a different name, your Apex dev, your test, and your prod environments. That means that you can move an application or even small parts of the application, components or pages, from one environment to the other because those workspace IDs and the application IDs can be the same in all three places. So app ID and alias stay the same, and the partial export and partial import is supported in that configuration. That doesn't work if you adopt the second approach that I'll talk about next, but might be required if you only have a single environment. It just means you can't do those partial export and imports. If you only have one Apex instance, you of course can set up separate workspaces, have a dev workspace, a test workspace, and a prod workspace with possibly different schema names because you'll be making database changes in development that won't be ready for test yet and won't be ready for prod. So having separate schemas is important. But that means because of the requirement that the application ID be unique across the whole instance, that means that your application 1001 in the Apex Dev workspace needs a different ID when you install it into the test workspace, and a different ID again when you install it into the prod workspace. So you might have an approach like put a 10,000, add 10,000 to the number, add 20,000 to the number, so that at least the numbers kind of are related, but it's important to realize that those numbers have to be different and the aliases have to be different for those apps. So you might choose the best looking alias like conference for my conference app example. That might be the alias for your prod. And then in development, your alias might be conference dev and an alias of conference test. But you can make that choice. The important thing is to understand that's required when you choose the separate workspace approach. So how do you move an application build from one environment to the next? The way that you do that is you first create a build of your application. We did that by making a zip file of the exported files from Git. So now you have a zip file. The way you install that is you unzip it to produce a directory of files, and then you install the Apex app and run the database changes against the target database. So again, I have a script that I've created to automate the commands that extract the zip file, install the Apex app by running the install.sql script, and then run the command which applies the database changes called lb update to the target environment. And so it just takes a few parameters, the zip file name, the application ID, the target workspace, and the database connection. And that's the only thing that are changing every time. So a script is a nice thing to automate that step. So you're not typing a bunch of commands that are almost always the same with just a few changes in them. If you're installing into a different workspace, the script might allow you to also specify a new alias, which would be helpful since, as we just mentioned, in that setup, the alias needs to be different. So let's take a quick look at some of the ways that a larger team might utilize functionality provided by Oracle or other vendors to inspect for performance problems, security violations, or possible security violations, and just ensuring quality at an even lower level than your unit tests. So the first thing to be aware of is the Apex Advisor. That's a built-in feature under the app utilities of your Apex Builder environment. It has about 30 different types of audits that it can perform on your application. Some of those are related to SQL, others are related to best practices. It's always good to run the advisor over your app and review what feedback it gives you. Another thing you can do is static analysis of the PL/SQL and the JavaScript code from your application. And there's a special export type that I wanted you to be aware of that's called embedded code. It's one of the things you can add to the exp type flag of the Apex export command. And by providing the embedded code option, you'll get an extra directory called embedded, which will have one file for each page that has the SQL and one file for each page that has the JavaScript, so that you have that separated to feed into other tools that might perform that static analysis. You might use the SQL set code scan on and interactively test certain SQL statements from those files, but that could be a little bit, if it's a big application, that could take a while. And so that code scan also in SQL supports an option in the latest versions called code scan with a dash path option that allows you to point it at the embedded code directory and scan the entire directory for recommendations about the SQL statements and PL/SQL code that have been extracted from your application for static analysis. You'll get a report. You can review those. Code scan may have some other options to study in their documentation. For example, maybe to suppress warnings that you don't consider a problem. If not, perhaps a future version will support that. There are also external tools like Apex Cert, which is an open source security scanning tool, and a third-party Apex SEC, Apex Sec, has a similar tool for auditing security best practices about your Apex apps that are useful to know about. And finally, a tool like SonarQube, there are modules that can do static analysis on PL/SQL or JavaScript code. You can take advantage of that and run those on the exported files that the embedded code export produces. So let's walk through a typical kind of end-to-end demonstration for how a development team, or in this case, one developer, will make a change to an application. Let's take an example of a medical clinic scheduling application. We've got some office staff and end users. We have Leo, the low-code developer, will make a change to that application. And let's take a look walking through the steps that we've talked about so far in this presentation. So the demo scenario is that the end users, David in the office staff, would really like to see a preferred date that the patient wants for an appointment that has to be scheduled. And the application does not currently provide that functionality. So David asks for a feature that gets logged in the ticket team development system. And then Leo will proceed to add a new column to a table, extend a view that already exists to include that new column, adjust some REST API that's part of how a mobile app might be interacting with the application to accommodate that new preferred date piece of functionality. Add that test, add that to unit tests, and then finally add the preferred date information to the page in the Apex application, and then test, and produce that new feature in the production environment. So we're going to walk through all the steps that we've talked about and show how that might look for Leo, the low-code developer here. So Leo sees a nice new feature in the team development area he wants to work on. He assigns that ticket to himself. He begins in the SQL workshop in the object browser to, in the development environment, add a preferred date column to the patient procedures table. He goes in the object browser in his development environment to adjust a database view to include that new preferred date column. He goes always in the object browser to the PL/SQL package procedure that's used by the REST service to include the preferred date in the logic of that REST service. He modifies the unit tests for including the preferred date column as part of the tests. He can run interactively his unit tests and make sure that all the tests, including the new tests, run successfully. And then finally, he can adjust his page in the Apex Builder using HTML directives to conditionally include the preferred date if it's provided in the page at runtime. His team has broken down the application into 3 mini apps. And so he uses a script that automates the export of his application to Git, like we've been talking about. It's not exactly the script I talked about, but one that he adjusted to export all 3 of the mini apps. He exports those to Git. He reviews those with VS Code, and he can review all the changes to the database export XML files, as well as to, for example, the pages that where he included some advanced formatting. And finally, commit those changes to Git and push them up to the Git, in this case, GitHub repository. I was using my private repository to do this example. So instantly I can see the changes that were pushed into the team repository up on GitHub. Finally, he'll run a script to create a zip for a build and deploy that build to the production environment. Finally, use a tool like Postman to test out the new REST service with the preferred date. And finally, exercise the application to see that now the end users will see a preferred date on the screen where they need to schedule a patient procedure at the Woods Clinic. So that's a short end-to-end example of stepping through the life cycle of picking a feature to implement, modifying the database structures, adding some tests, doing your testing, reviewing the diffs, committing that to your source control, and then finally packaging and producing, installing that in your production environment. So in the last few minutes, we'll talk about the differences between team-centric and feature-centric development. With team-centric, we talked about that's appropriate for teams of small to medium size that can work well with the working copy feature. Each developer will create a working copy to create the changes that are necessary in their separate working copy before maybe merging back to the main and periodically running a script which will export the main application and commit that to the Git source repository from the dev environment. Larger teams might want to do what I call feature-centric development, where each developer is working in a completely private Apex environment, and then they use a team development instance as the integration point for those different separate environments. Always making sure, as we talked about before, that each environment has exactly the same workspace ID and exactly the same application IDs, so that the only changes that are in the exported files are the interesting ones that the developers have made. So in that scenario, each developer works in a completely separate Apex instance. They might have their own pluggable database to achieve that, using database cloning features. They might install a local free 23C free Oracle or Oracle XE Apex, carefully created with the right workspace ID and using the same app IDs to be that local Apex environment. But then when they're done, they can merge, export, and merge those changes back to the team central environment. And use a dev instance as the place where the current main application that includes all team development changes has been integrated into. A new build will get pushed into that environment. And in the last section, we'll talk briefly about what solutions exist to go beyond running the scripts at the command line and really automate the execution of one or more scripts at different points during the life cycle. And so there are a number of popular automation platforms like Jenkins, GitHub Actions, GitLab has a CI/CD feature, Oracle OCI DevOps, and Oracle VB Studio. The last two options are both available on the Oracle Cloud. Teams choose their favorite option, and they all perform similar tasks of creating what's called a pipeline or a set of steps that will run a number of scripts. And the things that each of these automation pipelines do are exactly the things we've already been talking about: running scripts which export, create zip files, check into source control, deploy a zip file to a target environment, but they do that in a more automated way. So let's quickly see what you can do with one of these platforms. I'm going to choose Jenkins as the one I experimented with myself, but whatever we talk about can be done in all of these solutions. So for each set of steps you might want to do to orchestrate a set of scripts to be run, you can define a pipeline, which is configured as a set of stages or steps. Each one might interact with source control, perform scripts at the operating system command line, and connect to databases to export or import operations. Every one of these tools comes with a kind of a dashboard. This is what the Jenkins dashboard looks like, where you can see the set of machines that are being the workers for processing your pipelines. Whenever they get run, you can run them manually or trigger them based on source control operations, like a commit to Git might automatically start one of these jobs or pipelines. One of the pipelines I'm showing in the example might export our application and check it into source control. Another one might create a build zip from the latest release and deploy to a test environment and run the unit tests to report on whether the tests are all passing. Setting up the pipeline is a simple set of script, similar looking to JSON, which you define the stages, what script should be run, which connection credentials should be used. Pretty straightforward stuff that you can just do in your favorite code editor. This particular example has 3 steps. First, it downloads the latest SQL CL from the GitHub from Oracle. It exports the app with the credentials that it needs, and then it commits that to source control. Each time the job runs, you can see the progress it makes in the dashboard that the tool provides, and run the unit tests, saving the results to view later in a separate dashboard. And on the main page of the dashboard for each pipeline, you can see when it last run, whether it produced a build, whether it produced test results, and how quickly it ran to get an idea of how long it might take in the future. So the last successful artifacts give you a place where you can download your latest build, as well as review the unit test results and see that all the tests pass, for example. So in closing, let me just summarize the recommendations that we make to simpler apps and smaller teams where a team-centric approach can be effective to track your issues, maybe using the built-in team development, work in the shared environment using working copies, using Git or your favorite source control to export files and check in on a periodic basis. Use the open source utilities available to unit test your business logic and your UI. Committing team progress to that the repository at various milestones, and keeping those separate dev, test, and prod environments. For mission critical teams, probably a feature-centric approach, maybe an even more elaborate Kanban board way of tracking where you start to want to use Jira or other types of more feature-rich tracking systems for doing that. Using separate branch instances of Apex to keep that totally isolated environment. And then maybe going a little bit farther in the static code analysis and security to validate, doing more effort in validating the security of the application, given the mission critical nature. So all of this information is available in a technical paper that you can download with this QR code or these URLs. And the Apex Forum is the place where you can ask myself or other teammates or fellow community members questions about doing a great job with your Apex app and keeping it managed along the full life cycle to deliver sets of good new features and bug fixes to your end users. And with that, thank you so much for your time. If there's time, we can take questions. Otherwise, maybe my colleagues have been answering those in the chat.
Thank you, Steve. I have a few more slides before we close for the day. Thank you, Steve. That was an exciting and insightful session. I hope all of you have a better understanding of the Apex application development lifecycle today. Moving on, as most of you might have noticed already, we have the Oracle Apex trainings and certification page available on apex.oracle.com. You can use it. You can also visit by using the URL apex.oracle.com/go/training. So we have Oracle Apex Foundations codes, developer professional codes, and you can also get certified by using the provided link available in this particular URL. So regarding certification, you can always become an Oracle Apex Cloud Developer Certified Professional. Before we going and taking up the certification, we recommend completing the developer professional course and perform the hands-on labs that comes along with that. So all the best for your certification. And if you are having any questions related to Apex, or if you are a partner helping customers building innovative Apex applications, or if you're a customer seeking help in Apex, or if you want to present yourself in the upcoming Jetpack officers or global officers, any officer sessions, feel free to reach out to us. We have the link provided, Oracle Application Express _ww@oracle.com. You can always reach out to us for any queries related to Apex. Okay, and if you have missed any previous officer session, you can always watch the recording by visiting apex.oracle.com/go/playlist/Jetpack. So this is for Jetpack officers. You can also visit the recording of global officers as well. We have a playlist available. You can simply visit Oracle Apex YouTube channel, and you can always go and check out the videos available there. Okay. And if you're looking forward to learn more about Apex, we have already discussed apex.oracle.com is a one-stop solution to learn anything and everything about Apex. You can visit various shortcut URLs like Apex Shortcuts, Community, Blogs, Apex on Autonomous, and database cloud services, etc., by using the links provided in the screen. Yeah, thank you everyone for joining the session. Looking forward to meeting you in the next JPEG officers on March.